Okay, so in the last video, I had some technical problem and I couldn't go further. So let's talk about again why on this side the integral converge. Again, the denominator is getting bigger and bigger and bigger. So power is getting bigger. So when x goes to infinity, it converges. Again, on this side, you sometimes, if you notice that if the exponent is a bigger than 1 and if it is a near the horizontal asymptote, you do not need to evaluate the entire integral. You just can say that the integral converge. Now, on the other side, what happens if the integral is less than 1? We saw all those examples, which was integral greater than 1. What happens if it is a less than 1? So it's the same thing, x to the 2/3, you can say here. Um, First of all, remember you have to make it proper integral. So use the limit statement, limit b goes to infinity, 1 to b, x to the negative 2/3. Okay, remember the log rule comes only if it is a power is a 1. So this is a normal power rule, which means x to the negative 2/3 plus 1 is a 1/3, divide by 1/3 is a 3x to the 1/3. And bounds are 1 and b. Limit b goes to infinity. So what will be this is you can clearly see, this goes here. That goes to 3b to the 1/3 minus 3. Now, b to the 1/3 is a cubed root, but you know that the cubed root, even if it's a slowly, but it is still goes to infinity. So this piece becomes infinity. Infinity minus 3 is diverge. So what that makes is if this kind of function, if the power is less than 1, then it diverge. If it is a greater than 1, it converge. Less than 1, we diverge. We just proved it here. So let's take a look at these two examples here. Without doing all the work, what do you think of this? It will converge or diverge? 1.1 is greater than 1, so this will converge. And x to the negative 7, which you will have to rewrite as 1 over x to the 7. And you can see it fits the pattern here. P is greater than 1, it will converge. So I'm bringing those back. 7 is greater than 1, it will converge and converge. Unless it's asking for find the answer. Normally, the small ones are always in a multiple choice question. Which of the following integral converge? Which of the following integral diverge? Remember, we are going to see this again, same integral, same, but with a series symbol. So you will repeat all of these again in unit 10. So let's take a look at slightly complicated problems where we have to apply more than one technique. Now on the cover page, on the first page, we saw that how 1 over e to the x converge. And for that part, it is the same thing. I'm just going over this. B goes to infinity, e to the negative x. Entire derivative of e to the negative x is negative e to the negative x. And bound is 1 and b, which means f of b minus f of a. B goes to infinity, negative e to the negative b. So you must have a very clear idea how this function would look like. E to the negative b is exponential decay function, and negative sign makes it reflection across the x-axis. X goes to infinity, that means this number becomes 0. And 0 plus 1 over e is 1 over e. So we proved that this integral converges. Now this is exponential decay function near the horizontal asymptote. Exponential decay function near the horizontal asymptote. This is not the same as this. These are all 1 over x to the p. These are rational function with a denominator as a polynomial, but not the whole, only one term, x to the p, smallest, cutest, easiest integral. Now, unfortunately, those we're talking about multiple choice questions. Improper integral questions, we have seen several years for free response question. We have seen this as a free response question. So in your packet and page number 48, example 4b is a past AP question. Now mine and yours would look slightly different because I have handwritten that. So this is the question. 0 to infinity 2 dx x squared plus 4x plus 3. Now, one thing for sure that we know that how to make it proper, but how to evaluate this integral? What technique of integration would you use? Is it possible to do the u sub? Clearly, no. You can't use the u sub. Then comes PFD. So you have to do the PFD. So normally rubric says 1 point if student write limit statement, which we earn the first point, limit statement. Second point you earn by breaking into two, PFD, which is negative 1 over x plus 3. You can use a finger method and find those coefficients. Now, third point is evaluating this integral, which is negative ln x plus 3 plus ln x plus 1. My bounds are 0 and b. Remember, never write infinity here. You must use the limit statement because fundamental theorem of calculus cannot be applied to something which does not exist. So, okay, we did this. Now we are going to do the log plus log, log minus log, and we have to find the answer. So what I did here is I combine as a single log. Now you could keep it as a log plus log, log minus log, substitute b and 0, but at the end you still need to know what is the answer, converge or diverge. If I keep it b minus b, ln b minus ln b, then you will come across infinity minus infinity, which is not 0, and you have to use L'Hopital's rule. So let's talk about here. If I am going step by step, and this is a really, and expect something like this in the test all the time because they are very popular in AP exam. So ln x plus 1 over x plus 3. If I substitute b, ln b plus 1 over b plus 3. And this becomes ln 1/3. Now your job is to figure out what happens to this piece of term. B goes to infinity, infinity over infinity, which is improper integral, but improper, I'm sorry, which is indeterminate form. My bad. It is infinity over infinity is indeterminate form. So you could use a L'Hopital, but fortunately, limit statement is such a sneaky one which could go inside also. And you have to understand, I'm just pointing out limit b goes to infinity, b over b, which will become 1. You apply the limit statement to this piece with the ratio of a same degree is a 1 and ln 1 is a 0. So answer is negative ln 1/3. You can stop here or you can stop here. Make sure you go over this one more time because this is a really important information and really important questions, and you will have a similar kind of questions in the homework as well. Okay, so now we'll take a look at another example here, and then after this I will be stopping here. So now you have another combination where improper integral and integration by part. Really nice example here. Improper integral, integration by part. So let's check how we work on that. So first of all, choice of u and dv. U is 1 minus x, dv is e to the negative x. Derivative of 1 is 0, derivative of negative x is negative 1. Antiderivative of e to the negative x is negative e to the negative x. Keep finding antiderivative in this column, keep finding derivative on this column, and then you build the expression. So this is a really cool example where we do the improper integral with integration by part. So we start making, so this will be your first term. 1 minus x, negative e to the negative x. This is your second term, negative e to the negative x. And the third is a 0, so we do it 1 to b, which is ftc. Now this is one, if you apply 1 to b, is a 1 minus 1 is a 0, and 1 minus b, this is e to the negative b, and I have distributed and simplified. So there are 3 terms, 1, 2, and 3, because I distributed these 1, 2, and 3. You put 1 to b, so b over e to the b. And this piece is what happens here. If you apply b goes to infinity, that will be infinity over infinity, and you cannot say it's a 1. So here you could use your knowledge of dominance. You can say this is a bottom heavy, and bottom heavy means this number becomes 0, and the final answer is negative 1 over e. This is a really, really good example. So let's take a look at this last two examples. One was a improper integral PFD. This is improper integral, integration by part. Hope you have learned something, and if not, watch this video again and again and make sure you know this. Thank you.